Alright, well in this recording we're going to be looking at problem number 7. This is from the Exam 1 review sheet for Math 200. There's actually 6 parts to problem number 7. We're going to start here with part A. So what we're given is we're given the expression a squared times b cubed, but then all of that is raised to a power of negative 3, and our task is to simplify the expression. Now, when I simplify an exponential expression, one of the first things I typically do is, if I have multiple factors that are enclosed in parentheses and raised to a power, I invoke the rule that says that powers can be distributed across multiplication. So this can be rewritten as a squared written to a power of negative 3 times b cubed to a power of negative 3. Okay, so I just distributed this power to each of these products. Now I'll make use of the rule that says if I have a base raised to a power, but then the whole thing is raised to another power, I can multiply those powers. So 2 times negative 3 is negative 6, so I get a to the negative 6, and likewise I get b to the negative 9. Now it's generally understood in these problems that for our final answer we will convert all of our powers, or our exponents, back to positive exponents, and in this case we can do that by moving these factors to the denominator. So I'll rewrite my final answer here as 1 over a to the 6th b to the 9, and that's really all there is to do for part A. Alright, let's move on down to B. So in B, we're given the expression negative 8 over x squared over 2 times x cubed. Okay, now I can start by simplifying negative 8 over 2. Negative 8, when you divide it by negative 2, gives negative 4. So I can treat it as though the top becomes negative 4 and the bottom becomes just a 1. Okay, now with the x squared and x cubed, I can subtract the powers. Okay, I can subtract the lesser power from the greater power. When I do that, that leaves me a power of 1 on x in the denominator. And the x squared is kind of like the 2. It completely canceled out, so it just leaves a 1 there. So, simplifying, the numerator is now just a negative 4. The denominator is now just an x to the 1. And we would typically write x to the 1 as just x. So my final answer for part B is negative 4 over x. Alright, well, moving on down, we can have a look at part C here. So in part C, we're given the expression 5x squared over 15x cubed, and then all of that is raised to a power of negative 2. Now, a moment ago I distributed a power over multiplication, but powers can also be distributed over division. Okay, so really I can treat this as I have 4 factors in here. 5 times x squared, but then since I can also distribute powers over division, I've got a 15 and an x cubed. But you know what? Before I even do that, I just noticed I could do some simplifying inside the parentheses, and I think it would actually be better to do that. So let's do that first. Now 15 and 5, okay, 15 goes into 5 goes into 15 3 times. Okay, so I can cancel a factor of 5 out of both the numerator and the denominator. That leaves me a 1 in the numerator, a 3 in the denominator. And then with the x squared and x cubed, that's similar to something that happened in the last problem. That leaves me just 1 factor of x in the denominator. So now inside the parentheses I just have 1 over 3x, and that's raised to the negative 2. Okay, now I can distribute and have 1 to the negative 2 over 3 to the negative 2 times x to the negative 2. Okay, my power can distribute through all 3 of these factors. But of course 1 raised to anything is 1. So the numerator is still 1. So I have 1 over 3 to the negative 2 times x to the negative 2. Again, I don't want to leave negative exponents in my final answer. So in this case, since these factors are already in the denominator, I'll move them to the numerator. And there, their exponents become positive. And then it's convention with something like 3 squared, if that would still be pretty simple after we evaluate it, to go ahead and turn that into, in this case, a 9. So I would write my final answer for part C as 9x squared. Alright, let's look at part D. Alright, so in part D, I'm given the expression y squared to the 3 divided by 2 times y to the negative 3 to the 2. Alright, well, let me see. I can go ahead and use the rule that says if I have a base raised to a power and then raised to another power, those powers will multiply. So that becomes y to the 6. Now, in the bottom, I can use the rule that says powers can be distributed over multiplication. So there's 2 factors here, 2 and y to the negative 3. So I can distribute the power of 2 to the 2, but also to the y to the negative 3. Alright, so I'll keep my numerator as y to the 6. 2 to the 2 is 4. And then y to the negative 3 squared becomes y to the negative 6. Okay, now I see that I have something raised to a negative power, so I'm going to move that from the denominator to the numerator so that its power becomes positive. So now I have y to the 6 times y to the 6 over 4. And then there's one more step to take here. Since these 2 factors have the same base, there's a rule saying I can simply add their exponents. Okay, so 6 plus 6 is 12. So this becomes y to the 12 over 4. And that's how I will leave my answer for part D. Alright, let's move on down and have a look at part E. Okay, well, I think for starters, in part E, I will go ahead and distribute this negative 2 over the product x to the negative 3 times y. Okay, when I distribute the negative 2 to the factor of x to the negative 3, the powers multiply. Negative 2 times negative 3 is 6. When I distribute it to the y, I just get y to the negative 2. And then I'll do something similar in the denominator. This 2 needs distributed to both of these factors, which means it needs to multiply with both of those existing powers. So I'll get an x to the 4 and a y to the negative 10. Alright, well, I see some negative exponents, so I'll take the factor that has a negative exponent in the numerator, I'll take it to the denominator, and then vice versa, and that will make those exponents positive. So I can rewrite this as x to the 6 times y to the 10 over x to the 4 times y to the 2. And now I can use the rule that says if I'm dividing and I have the same base, I can subtract the powers. So x to the 6 over x to the 4, 6 minus 4 is 2, so that becomes x to the 2, and then 10 minus 2 is 8, so then I get y to the 8. There are no factors left in the denominator except 1, so I don't need to write a denominator. And my final answer will just be x to the 2 times y to the 8. Alright, one more problem to do, part F. Okay, but just another simplifying the exponential expression type problem. Similar approach. Everything inside the parentheses is either multiplication or division. Powers can distribute over both of those operations. I'll just mention briefly that the two things they don't distribute over are addition and subtraction. But that hasn't really been an issue with any of these problems. Now, as I distribute this -2, it's going to multiply with each of the existing powers. So -2 times 3 is 6. I'm sorry, -6. So I'll get x to the -6, y to the -4, but then a z to a +2. And then let me see, -2 times -1 is 2, so I'll get x to the 2, and y to the +4, and then finally z to the -6. Alright, now I'm going to take each factor that has a negative power and either move it from the numerator to the denominator, or if it's already in the denominator, I'll move it up to the numerator. So it looks like in the numerator, I'm just going to have the z to the 2 that's already there, and also a z to the 6. Now in the denominator, I'll have the x to the 2 and the y to the 4 that were already there, but I'm also going to pick up an x to the 6 and a y to the 4 coming down from the numerator. Alright, now I'm going to use the rule that says if I'm multiplying things with the same base, I add their powers. So z to the 2 times z to the 6 becomes z to the 8. And then x to the 2 times x to the 6 becomes x to the 8. And then finally y to the 4 times y to the 4, 4 plus 4 gives me 8 again. So my final answer for part F will be z to the 8 over x to the 8 times y to the 8. And that's it for this problem, so we're going to go ahead and wrap up there.